Mr. Santosh Kavre sir completed his master degree from Dr. Baba Saheb Ambedkar Technological University, Lone in Power System Engineering. And currently he is working as an additional executive engineer at MSCTCL, Navi Mumbai. Previously, he worked in operation and maintenance at 500 kV bipole HVDC terminal station and 400-200 kV substation, Padage, MSCTCL, Thane, Maharashtra. He has also done a lot of outstanding activity during his job, like design aspect, operation and maintenance of 400 kV, 220 kV, 100 kV, and 222 kV extra high voltage and high tension substation. And today the topic of lecture is artificial intelligence, machine learning applications in HVDC transmission system. So I would like to request Mr. Santosh Kavre sir to deliver the lecture. Thank you. So welcome Santosh Kavre sir. Please start the session.
Thank you so much, madam, for this kind introduction and words of appreciation. So, rather than taking much more time, just we will start about this subject. So, the today's topic, that is AI ML applications in HVDC systems. So now many power industry experts and analysts are saying that now there will be the era of AI, ML and ANN, so which is going to do the revolution of power sector. Means our conventional control and protection system in few days will be going to replace by with AI, ML and ANN. And the people who are actually understand this technology and work in this technology will be the shining stars in upcoming days. So this is the one of the prediction of the power industry experts and analysts. So already there are two sessions which are already taken by some speakers, and already they talked about basics of AI, ML and ANN. Also how to do programming in Python. So that portion is also covered by Dr. Bakre sir. So just in few words, I want to say that this artificial intelligence, machine learning and deep learning, when we go into the depth of these technologies, then very advanced control and protection system we can develop. And today how that is possible, that we will see in HVDC perspective. So regarding HVDC, people say that HVDC is a complex system generally, because there are many more systems are interconnected in HVDC. Like there is a AC switch yard, DC, then thyristor walls, then DC switch yard, transmission line, DC line. Then again, if it is a current source converter technology, then there is a, we can say, electrode station. So there are many more parts are there in HVDC, and accordingly we have to arrange their controlling and protection. So that is a special design aspects of HVDC. But rather than we can say it's a complex, we can say it's a very simple system, because if we don't have knowledge of anything, then we feel that it is a complex system. But when we go into the depth of that whatever technology or knowledge, then we will come to know that it is very simple. Just ignorance is, we can say, that is the just giving illusion of that is we don't know, or it's a complex system. So simply I can just compare here HVDC with our battery systems. Suppose I have two batteries. One is here, this is one battery here. Suppose it is 2-volt battery, and here it is 2-volt battery. each battery has two terminal. One is positive terminal and other is a negative terminal. So this another battery has positive negative terminal, and in HVDC we can say it's a simply battery analogy. So actually this is a battery, but the difference is that it's a variable battery. That is the simple difference. It's a this our rectifier is a AC to DC converter, which is like a battery, positive pole, negative pole, and just it is a variable source. Then we have inverter which converts DC into AC. Again similar, it is a battery, but it's a variable battery. And in between that there may be the transmission line, overhead transmission line, or underground cables, undersea cables you can use as a transmission medium. So that here in the DC side you will have a smoothing reactor, then line has certain resistance because their XL and XC is absent in we can say XL is 0 and XC is infinite in HVDC. So that's why there is only resistance to the line. So this portion we can say it's a resistance. So just these are the two batteries connected in parallel through this transmission line or cables. Just simply we can say battery analogy with HVDC. Now we'll see here, this is a converter station. It can be called as a rectifier which convert AC into DC. So first of all, if it is a current source converter based technology, so AC supply must be applied to the walls, thyristor walls, through the converter transformers. Converter transformers are essential in case of thyristor based technology, but it is not essential for the voltage source converter based technology. Then these are sometimes called as HVDC transformers because these are specially designed transformers. I am requesting to all participants, please mute the microphone so that it will not disturb to anyone. Then we can say that there is overhead line or cables also can be used as a transmission medium. Here inverter we have which convert DC into AC with again here converter transformers, and there is again AC system. So this is we can say HVDC transmission system. But while designing the control and protection system, you have to take care of all these things which are interrelated, and there are many more things which we have to taken into account, like thyristor cooling system. That also you have to think, fire protection system. So there are many more things which you have to consider while designing the system. Now this is a simple one video here which is showing different areas in the switch yard. That is this is the AC switch yard. These are converter transformers. Then we are having a thyristor walls. These are thyristor walls, and this is the DC portion, and these are the harmonic filters, and sometimes shunt capacitors are also used to provide more reactive power if there is a, we can say, deficiency of reactive power in the system. So this is the structure of conventional HVDC, that is current source converter based or thyristor based HVDC. But voltage source converter based technology will be quite different because it's a very advanced compact system, and there are many more components which are not used for the voltage source converter, that is IGBT based technology. So here converter transformer, there is no need of converter transformer in case of voltage source converter technology. Then another, the simple filters or sometimes filters are at all not required because there is a PWM technique used where all the harmonics shifted on the higher side, and there is no need of filters in, especially if you talk about the MMC, that is modular multi-level converter based technology. So means there are continuous development is going on in the field of HVDC. Now we are in the very advanced version of HVDC that I will talk later on also. So this is the DC portion, and here DC filters are there to eliminate the DC harmonics. Here AC filters are used to eliminate AC side harmonics, that is odd harmonics, and on the DC side we have even harmonics. Filter has two purposes in case of AC side filters, that is harmonic elimination plus reactive power support. Because conventional HVDC, thyristor based HVDC needed 50 to 60% reactive power at the terminal station itself. So that conversion is possible after applying that much 50 to 60% reactive power. So this is a conventional technology. These are the thyristor walls. Maybe generally suspended structures are used. Now there is a development that is we can say mounted structure walls are also coming. So there is much more evolution. There is another technology that is capacitor commutated converter technology, that is CCC HVDC. So that is also one of the development in HVDC. So where in between converter transformers and thyristor wall there is a series addition of additional series capacitors for the reactive power support of the DC link.